Today we have to understand what is differentiation. Differentiation. So let's say that you are traveling in a car which is going with some speed on a road, and at different times you just notice the distance covered. So at t equal to 1 second, distance covered is 1. At t equal to 2 seconds, the distance covered is 4. At t equal to 3 seconds, the distance covered is 9. So like that, you have these points. Now suppose, let's say that you have been measuring the distance at each and every time. So instead of just isolated points, you'll have a graph. So this is what we can call as S versus T graph. You can say that S is a function of T. Functions means what? Basically just a rule. So here you can say that S is equal to T square. So you see at T equal to 1 second, it is 1 square, that is 1. T equal to 2 second, it is 2 square, that is 4. T equal to 3 second, it is 3 square, that is 9. So now here, let's say that you want to find out the average speed. Okay. So between t equal to 1 second and t equal to 3 second, if you want to find out the average speed, so what would you do? You would find out the total distance covered between 3 and 1 second. So I'm writing that as S3 minus S1. S3 means distance covered up to 3 seconds. S1 means distance covered up to 1 second. Divided by the time taken, T3 minus T1. Okay, this we can also represent as delta S by delta T. Here delta just means change. Okay, don't cancel out delta and make it S by T. That is not the meaning here. Delta is just a symbol. It's not delta into S here. Okay, so now you have to understand that what does this mean in the graph. You see S3 minus S1. S3 is the distance here, no? And S1 is the distance here. So if you make this triangle complete, A, B, C, it would be right angled at B. And let's join AC also. And this angle, let's say it's some theta. So what is delta S by delta T? That is nothing but AB upon BC, isn't it? Which is tan theta. So this is also known as slope, because you can understand, no? Because AB is what? AB is like the height covered, and BC is like the distance traveled to cover that height. So if you're going along a hill and you are able to cover a very high value of AB, while going for a very low value of BC, you would say that the hill is very steep. It has a very high slope. So that's why this is known as slope. So this thing here, AC, as you would recall from geometry, is known as a secant. For a circle, you would remember that what is a secant? A secant is a line which intersects the circle at 2 points. So basically what you're getting here while calculating the average speed is the slope of the secant, isn't it? Now, how much would be the average speed between t equal to 1 and t equal to 3 seconds? So I'm making a table here. Here, the initial time, the final time, the distance covered, the time taken, and the average speed. Okay. So if you make that table, initial time 1, final time 3, distance covered is how much? S3 minus S1. So that is, in this case, how much? 9 minus 1, so 8. And T3 minus T1, so that is 2. So average speed is how much? It's 8 by 2, isn't it? So that is 4 meter per second. So similarly, if you want the average speed between t equal to 1 and t equal to 2 seconds, what would you do? You would find out what is the value of S2. minus S1 divided by T2 minus T1. So that would slope of this secant. Let's call it. Let's name it D and this one E. So it would be the slope of T. Okay. So here Ti is equal to 1, Tf is equal to 2, and distance covered is how much? 4 minus 1, that is 3. And time taken is 1 second, so average speed is 3 seconds. Okay. Now, our aim, suppose, is to get the exact value of speed at, say, t equal to 1 second. So how would you do that? What would you do? You would go close to 1 as close to 1 as possible. Let's say you calculate between t equal to 1 and t equal to 1.5. So at t equal to 1.5, what would be the distance covered? According to the rule here, s is equal to t square. At t equal to 1.5, the distance covered should be 1.5 square, which comes out to be 2.25. Okay. So 2.25 meter. So between t equal to 1 second and t equal to 1.5 second, distance covered would be what? 2.25 minus 1, isn't it? This much. So that would be what? That would be 1.25, and time is 0.5 seconds. So when you divide 1.25 by 0.5, what do you get? You get 0.5. So average speed is 2.5, and like that you can go closer and closer, as close as possible to 1. As I mean, using this method you can, like, from 1 to 1.1 you can go. Now 1.1 square minus 1 square, this would be your distance covered, isn't it? Divided by the time taken would be 1.1 minus 1. So it would come out to be 1.21 minus 1 divided by 0.1. So that is 0.21 divided by 0.1. So becomes 2.1 meter per second. So here delta S becomes 0.21, delta T 0.1, and average speed is 2.1 meter per second. And like that you can keep on going as close to 1 as possible. Now what would you do if you want the exact speed at t equal to 1 second? How to get that? So I'm again redrawing that graph. So this was the graph, something like this. So what you're doing, in going closer and closer to the equal to 1 second value, you're making seconds each time, isn't it? But the points are coming on the t-axis, is coming as close to 1 as possible. Now suppose, let's say you calculate between t equal to 1 and t equal to some 1 plus h seconds, okay, where h is any arbitrary value. Okay. So like in the first case, when you went from t equal to 1 second to t equal to 3 seconds, so the value of h would be what? 2. Yeah, good. So t equal to, and h would be 2 there. Similarly, in the second case, h is 1. In the third case, h is 0.5. So I'm taking a general case that you are going from t equal to 1 to t equal to 1 plus h. And by the formula that we have, we would know that at t equal to 1 second, you are at 1 square. That means at 1. And t equal to 1 plus h, you are at 1 plus h square. So your average speed would be 1 plus h square minus 1 square divided by t2 minus t1. Is that okay? So now what do you get? You
1 plus
you can use a square minus b square. That would be quicker. So you'd get a plus b into a minus b. Now a is this, b is this, a minus b would be just h divided by 1 plus h minus 1. So that would be h. Is that okay? So what do you get? Average speed as this much. Now you can cancel h and h. Okay. So you get what? 2 plus h. Is that okay? Average speed is 2 plus h. Now let's go back to the table and check whether this holds true for all the things that we have done or not. When you went from t equal to 1 to t equal to 3, h was 2, isn't it? And the general formula of average speed that we have got is 2 plus h. So according to this formula, when h is 2, you should get 2 plus 2, 4 as your average speed. Are we getting that? We're getting 4. When you went from t equal to 1 to t equal to 2 seconds, h was 1. So according to the formula, you should get 2 plus 1.
3.
And when you went from 1 to 1.5, h was 0.5.
1.5.
So when you went from t equal to 1 to t equal to 1.1, h was 0.1, isn't it? So t is 2 plus h. Average speed is 2 plus h. So you get the point, no? That no matter what is the value of h, we have found a general formula to get the average speed. Is that okay? Now you see, if you want the exact speed at t equal to 1 second, what should be h? You want the speed between t equal to 1 second and t equal to 1 second only, not between t equal to 1 and 1.1. Then in that case, h should be as small as possible, isn't it? But if you make h 0, the problem is that numerator will also become 0. 2 plus 0 into 0 is 0. And denominator would also become 0. Now this is something that we would always like to avoid, because this becomes undefined. We don't know what it is. Okay. So we say that we will tend h to 0. Now this is something that we really need to understand. Limit, this is the short form for limit, LT. Limit h tends to 0 means h is as close to 0 as possible but not 0. Now can you tell a number which is closest to 0? If you tell 0.1, 0.01 is even closer. If you tell 0.01, 0.0001 is even closer. If you tell this is the closest, then 0.00000001 is still closer. And you can keep on going like that. So you cannot actually represent this number. But you have an idea that it is a number which is as close to 0 as possible but not 0. So it has all the good properties of 0. What are the good properties of 0? If you add 0 to a number, the number remains same. Okay. If you subtract 0 from number, the number remains same. If you multiply 0 to a number, it becomes 0. What is the bad property of 0? When you divide something by 0, you don't know what it is. It becomes undefined, isn't it? When you when you have 0 by 0, it becomes undefined. So those are the bad properties. Now this thing is as close to 0 as possible but not 0. So what we can do, we can cancel. In general, if the numerator and denominator you don't know whether they can be 0 or not, then you cannot cancel. Only when you know that both of them are non-zero, then you can cancel it. So then you get what? Limit h tends to 0, 2 plus h. Is that okay? Now this will be equal to what? Now h and h is cancelled, so you're having 2 plus h, and h has to be as small as possible. So that means what will be the value here? It will become just 2. Is that okay? So because limit h tends to 0 is as close to 0 as possible, so on adding this thing to 2, it wouldn't change it. Okay? But you can divide by it and multiply by it and still have a finite value. Okay, so now in the graph, let's understand what's happening when you're making h as small as possible. We have seen that when h was 2, it was here. When h was 1, it was here. When h was 0.5, it was here somewhere. When h was 0.1, it was here somewhere. And when h is as close to 1 as possible, this point and this point would coincide, no? So in general, you're having a line, you're getting the slope of a line which is intersecting the curve at 2 points, at t equal to 1 and t equal to 1 plus h. But when limit h tends to 0, it will intersect the curve only at
1 point.
only at 1 point. Yeah. And instead of becoming a secant, it will become a tangent. So graphically, what does differentiation mean? It means finding the slope of the tangent at that particular point. Okay. So it basically helps you to calculate the rate of change of a function at a given point. So what we did right now is differentiation. We differentiated the function s is equal to t square with respect to t at t equal to 1 second. Okay. Now translating that into normal language would mean we found out how rapidly s is changing as you are changing time at t equal to 1 second. You see the way it is changing at t equal to 1 second, it is not changing the same way at equal to 2 seconds. It is changing even more rapidly at t equal to 2 seconds, isn't it? So if you differentiate it at t equal to 2 seconds, you'll get a even higher value. Okay. So just for your understanding, if you have a curve, any curve, and it is given that at this point, if you draw a tangent, then it is making an angle theta. Okay, at this particular point. So differentiation of this curve at this particular point would be how much? Yes, this is y versus x. So this is some y. This is how we write it, y a function of x. So differentiation of this curve at this particular point would be how much? It would be nothing but the slope of this tangent, isn't it? It would be tan. In general, when you find the average, it is the slope of the secant. But in differentiation, it becomes slope of the tangent. So that is the basic idea of differentiation.